go. We're going to do some problems with Pythagorean theorem and using 1.414 and 45-degree triangles. First of all, we're going to start off with a Pythagorean theorem question. Solve for side C. Answer feet, inches, and fraction. So remember, side C here is our hypotenuse. We're given side A, and we're given side B. So the first thing we have to do, we have to get all our dimensions to inches here. So 3 feet, 3 times 12 would be 36, plus 3, so we have 39 and 1/16. We get this fraction to a decimal, 0.06, so our number is now 39.06. For side B, 1 times 12 would be 12 inches, plus the 4.5, 16.5 inches. Again, we get the fraction to a decimal, and here's our number for side B. Okay, so now we're ready to use our formula. A squared plus b squared, and then we'll take the square root of it. Remember, when we square a number, we're timesing it by ourselves. We get this number here for that one, and this number here. So we're going to add them together, and we get this here. On your calculator, shift and square root, and we get a number, 42.40. We know how to get that decimal to a fraction, 0.40 times 16, 6/16. You know now to reduce that to 3/8. So we have 42 and 3/8, or 3 feet 6 and 3/8, because it asks us to answer in feet, inches, and fraction, right? Always read the question to determine how you need to convert your final answer. For this one here, solve for side B, answer in meters, 2 decimal places. So this time we're given side A, and we're given the hypotenuse. So when we're given the longer side, we need to do this. C squared minus A squared, but answer in meters, so before we do anything, you have to get this number to meters. You know how to get centimeters to meters. We divide by 100. There's our number in meters. So now we're good to go. 4.50 squared minus 3.75 squared. 20.25 minus 14.06. 6.19, shift and square root. We get 2.4879, 2 decimal places. We round that up, it comes out to 2.49 meters. And you're smiling just like this here now. All right, when we have 45-degree triangles, remember we need to use our magic number, 1.414. This will always work, and it will only work when we're dealing with 45-degree angles. So, what I mean by that is, if this is 90 degrees and this is 45 degrees, then this has to be 45 degrees. And when we have this going on, the measurement from here to here and the measurement from here to here has to be the same. And when we're looking for this side here, we multiply by 1.414. So here it's telling us our offset is 16 inches. 16 inches multiplied by 1.414, we get 22.62 inches. We know what to do. 0.62 times 16, look at that, we gotta round that fraction up to 10/16, and then reduce it to 5/8. So what's it say here? Answer in inches and fraction, inches and fraction. You're getting good. All right, the next one. For this time, we're given the travel, so we're given the longer side here. Calculate the rise, which is this side of the triangle right here. Answer in feet, inches, and fraction 16. Big surprise. So, the first thing we got to do here, we got to get everything to inches. So, 2 times 12 would be 24, plus the other 3 would be 27, and then that fraction to a decimal is where I get that 0.25. So, our number here is 27.25. So, this time we're given the longest side, and we're looking for the other side. So, when we have this going on, we divide by 1.414, okay? So 27.25 divide 1.414, excuse me, 19.27 inches, 0.27 times 16 would be 4/16, reduced to a quarter. Ooh, answer inches in fraction. I should have left it right there. See, I didn't read my question. That's what happens. So the right answer there is 19 1/4. Okay, just a few quick word problems, and then that's that. So when you're doing word problems, some of you are asking me, how do I know whether to use Pythagorean theorem or if I'm dealing in a 45-degree triangle? So a lot of times in your question, it'll tell you right before you start using a 45-degree triangle. And then in the next question here, there's a little bit of trick. You should be able to figure it out. So this first question here, a biker rides due east for 35.5 kilometers, then turns south and travels for 15.75 kilometers. How far is the rider from the original starting point? I'm going to answer this in 2 decimal places. So, draw out your triangles. So I'm hoping my south and east are right here, but close enough. Anyway, so we're going 35.5 kilometers east. Then we're turning, we're going south for 15.75, right? So there's our triangle. This is what we're looking for, right? So this dimension and this dimension aren't the same, are they? So we know we have to use Pythagorean theorem. So 35.5 squared plus 15.75 squared, right? We're going to add them together. We're going to hit shift and square root. We're going to go 2 decimal places, 38.836, and guess what? We round that up to 38.84. Done and done. The last question. A diagonal walkway through a park is 15 feet long. If the park is a square, how long is each side? Answer in feet, inches, and fraction to a 16. So, we have a diagonal walkway that we know is 15 feet. We know that this park is a square. You know, my squares are a little crooked sometimes, but the park is a square. So if the park is a square, right, all those sides have to be the same. So there's your triangle, right? And we know this side. We know the travel. So we divide that number by 1.414, and we get 10.61 feet, because this number was in feet, right? We know what to do here. We know we have 10 feet. 0.61 times 12, we get 7.32 inches. There's our 7 inches. And our 0.32 times 16, 5/16. Final answer, 10 feet, 7 and 5/16. Okay? Reading the question hasn't changed all semester long. It hasn't changed to when you're working out Pythagorean theorem. Converting numbers, feet, inches, and fractions. Doing it the same since September. So we're just adding on some more steps and some new concepts. See you next time.